Okay guys, we are looking at page 166 in our student journal. We're going to be talking about logarithms. Logarithms would be a new term for you. Logarithms are used when we're working with exponents. So when we have an exponential function, we can rewrite it as a logarithm. Some vocab right here, a common logarithm. This is a log with no base given. When no base is given, it automatically has a base of 10. So if you see something like this, log 4, there's a base down here that is not written, but if there is no base here, it's automatically 10. And that's because we use base 10. And the reason we use base 10 is because of our fingers. We have 10 fingers. So that's the reason we use base 10. If we had been born, with 4 fingers on each hand, we would use base 8. It's weird the way we'd count. We would go 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 20. You see how that would be so weird to us, the way we're used to it? But that's what base 8 would mean. Once you get to 8, you start over with your number system. We're so used to base 10 that we feel like that's just the only possibility, but it's really not. There are other bases out there that could be used. It's just that no one uses them until you get into higher level math. If you become like a math major or something, you'll take some pretty high level math, and you would use different bases. One of the most famous systems we use that's a different base is the binary system. Okay, that's a different number system. It's not base 10. It's going to be just base 2, basically. All right, natural logarithm. This is a log with a base of e that can be written as log base e of x or natural log of x. We use these e's all the time, so instead of having to write log, my base is e of 2, I can just write it as natural log of 2. This ln like this means natural log of 2. So I would automatically know the base is e without having to write it. So when we see it written like this, the base is 10. See it written like this, the base is e. All right. Definition of logarithms with base e. The logarithm of y with a base b is denoted by log base b of y and is defined like this. Log base b of y equals x, if and only if, which means these two are equivalent, b to the x equals y. Look at the pattern. Here's the base, here's the y, here's the x. If I want to rewrite this as an exponential problem, it goes log, and then this, when we start with log base b of y equals x, we find that base. That's the base of the exponent. But this now becomes the exponent, and this would be the answer. The expression log base b of y is read log base b of y. All right, let's do some problems. These are not in your notes, but I want you to get used to using a base of 10. So looking at number 1, there's no base given. So what is the base? 10. So now I'm going to put in that base of 10. And we're trying to figure out what this is equal to. So I'm going to just say it equals x so that I can solve it. So in order to solve this, I now have to rewrite it in exponential form. So to rewrite it in exponential form, I find the base. I go around like this. This now becomes the exponent. And this now becomes the value. So what is the answer to this? 10 to the what would be 100? 2, right? So the answer to log 100 is equal to 2. 2 would be our answer. I'd like to show you how to do that on your calculator. Get out your calculator. Find the log right here by the number 7. And just hit log 100 and push enter, and it tells you the answers too. So we can use our calculator to compute logarithms, but I expect you to be able to figure out logarithms without the calculator as well. All right, guys, so on this one, what's the base? 10. I'm trying to evaluate this, so I'm going to say it equals x. So now I'm going to find the base. I'm going to swirl it around with this pattern. Come back this way. And now I have to think 10 to what power would give me 10,000? What is it? 4. So the answer to log 10,000 is 4. That's our answer. If you wanted to check it, I can just do log 10,000 and I get 4. All right, I want you guys to try numbers 3, 4, and 5.
Use your calculator?
No, no calculator. This would be on the non-calculator part. Try it on your own. Don't look up here, but I will be working them up here. Karen?
Where'd you get the 0 from on number 3?
Because 10 to some power has to be 1. There's only one power that will give us an answer of 1. When the exponent is 0, anything to the 0 power is always 1, so I knew it had to be 0.
Okay.
Did you guys remember to write 0.1 as 1/10? And then the problem's pretty easy to do if you know that's 1/10. All right, so on the next one, number 6, my base is 10. So 10 to the x equals, now I want to look at this. This would be tenths, hundreds, thousandths, 10,000ths. So this is 1 over 10,000. All right, well look at what we did up here. We know 10 to the 4th is 10,000. So 10 to the what would be 1 over 10,000? Negative 4. So this answer would be negative 4. All right, so now we're doing some problems that have e's in them. So on number 7, I have natural log of e to the 5th. I'm trying to figure out what this is equal to. So I have to know that this is natural log. Whenever I see natural log, the base is e of e to the 5th. To figure this out, I say it equals x. And now I find the base. We swirl it around. This is now the exponent. Back to that middle spot. That middle spot right there becomes the answer on the other side. And so what would the answer to this have to be? Just what? 5. So this simplifies down to just 5. What do you think this one's going to simplify down to? Negative 2. To show that, we find our base. We say equals x. So we find the base. We swirl it around. We come back to that middle spot. And so I can see then that the answer is going to have to be negative 2 when we simplify that. And let me show you how I could even do that on the calculator. If you look at the calculator, you have a natural log button right next to the number 4. So I could type in natural log, got that, and now I have to put in e, which is right here. So I do second e to the negative 2. So look what I have. Oops. I want that to be of the whole thing. Okay, so I have the natural log of e to the negative 2. I push enter, and it supports the fact that it's negative 2. Okay, so not too difficult, but let's look at a few other types. We're not going to do the graphing today. We're going to save that for tomorrow. We're going to come down here on page 167 to the extra practice. All we have to do is to rewrite the equation in exponential form. So we're just going to write these in the exponential form. Right now they're written as logs. So find the base. Come over here to this and come back around. And when you're finished, it should be a true statement. Is 10 to the third 1,000? Yeah, so we know that we're correct. Go ahead and do the other three. Everybody good with that? Any questions? All right. Now let's go in the other direction. So we're going to be given the problems in exponential form, and you want to rewrite them in log form. So I'll do the first one with you. So this is an exponential form, so it's going to be log, find the base of the exponent is 12, so the base of the log is 12. This needs to look like a subscript. Sometimes people put it up here too high. It's a subscript of the log. So we go around, so it's log, there's our base. 144 is not a subscript. It's level with the log. And then you come back around, and that exponent now becomes the answer. And so this will be written log base 12 of 144 equals 2. Okay, so practice writing on the other three. Make sure yours look the way mine do. I've seen people who miss all of these because they write them in very strange ways. Like they think that 2/16 is the subscript, and they think 6 should be a superscript, and they put it like up there. That's not correct. It's log, this is a base, this is level with the log, and that is the answer on the other side. All right, so now we're going to evaluate the logarithm. So we're trying to do log base 4 of 64. So what that means is I'm going to say equals x. Anybody think they know what this would be? What do you think, myself? 3. So the answer to log base 4 of 64 is 3. Let's look at why. We find the base, we swirl it around, and so we have to think 4 to what power is 64? 4 to the first is 4, 4 to the second is 16, 4 to the third is 64. So therefore this answer is 3. And you really shouldn't say x equals 3 because it's asking us to evaluate this, log base 4 of 64. So we just want to put 3. Don't put x equals 3 because we actually put the x there ourselves. There's no x actually in the problem. I'd like to show you how to do this on the calculator with a different base. We can't just hit log because it won't allow us to change the base. But if you go under math and you scroll way down to letter A, you're going to see a log base. If you push enter, it allows you to change the base now. So I'm changing the base to 4, and this is 64, and the answer is 3. Okay? I would not put this problem on the calculator part, though. I'd expect you to be able to do that without a calculator. I want you to try the next 3 without the calculator. Tommy, what'd you put for number 10? 0 is the answer. Good. What about your answer for number 11, Justin?
It would be
5, right. So this answer would be -5. Okay, and what about this one? Does anybody think they know what this one would be? Marcella? -2? Let's see if that works. If I have 1 over 25 to the -2, the negative means to flip it, and then I'd have to square it. That's 625. Okay, so that doesn't work. Anybody else think they know? What do we need to do to the 25 to get 5? Take the what? The square root of it. We need to take the square root of it. So we need to say, what's the exponent that takes the square root? 1/2. Good. So if I make x equal 1/2, let's see if that works. So if I'm doing 1 over 25 to the 1/2 power, that means I have to do the square root of 1 and then the square root of 25. See how that does work? So anytime I want to take the square root and get the answer, my answer is going to have to be 1/2. What if I wanted to take the cube root? What would it be for the answer? 1/3, right? Like this, guys. If I had 8 to the what equals 2, what's this have to be? 1/3, right? 8 to the 1/3, that means the cube root of 8, that's 2. Okay. All right, number 13. We really have this problem where we've got 13 to some power, and we're trying to simplify. So when we do a problem like this, I'm going to say it equals x, because I'm trying to simplify it. So this is right now an exponential. It's 13 to the a equals x, or 13 to the y equals x. It doesn't matter that that's so complicated. All I'm doing is the same thing that I did right here in number 5. You all could do number 5, log base 12 of 144 is 2. So we're going to do that same process with this. Log base 13 of x equals, and it's equal to the exponent. So it's equal to the exponent. The exponent is log base 13 of 6. So can you see now what this would simplify to? What would it have to be? Just what? 6. So this answer then is just 6 right here. All right, on this one, it's a log right now. So how do I want to rewrite it? As a what? If it's a log to start with, we're going to write it as an exponent. Okay, so look at how we rewrote things as exponents. Let's go over here. So when we had a log, to rewrite it as an exponent, we did 10 to the 0 equals 1. So over here, what's the base though? It's not 10 now. What is it? E. And why would it be better for me not to call this x? We already have an x, so choose another letter. I don't care what you choose.
Y.
Y, sure. So now to rewrite this, I have to use my pattern. It's going to go e to the y equals e to the x to the third. So now what's the answer to this going to have to be then? What's it simplify to? Just what? X to the third, or x cubed. That would be how it would simplify. Okay? Those can be pretty tough. Let's have you guys try a couple in your free space here, see if you can get it. Let's do this. Log 10 to the x squared. Try that one. And then the other one I want you to try is, let's do 12 log base 12 of 5. are those two. Julia, do you think you know the first one?
I got x squared.
X squared, do we agree? Yes, that is correct. Here's the way it goes. I'm going to use a y. So it's 10 to the y has to equal 10 to the x squared. Well, that means then that the answer is going to have to just be x squared. All right, what about number 2? Number 2. Sarah, what do you think? Right here. Not sure. Anybody think they know? Tori? It is 5. Here's the reason why. On this one, I can say it equals x. And now I'm going to have to do log base 12 of x equals, swirl it around, log base 12 of 5. And so now can you see why it's going to be 5? Because it matches up exactly, so it's going to have to simplify down to 5. All right? Those are probably the hardest types, those last few that we did. All right, so this is a very important assignment.